Hi, I'm Renato, founder of GRIFORTIS, and today we are going to present the DuraShare, a BIP39 native threshold backup with full manual fallback and per share audit. Let's start with our GitHub repo. This is the specification repo. We have different repos for implementations too. And as I mentioned, DuraShare is a human-first, software-assisted K of n threshold backup, meaning you can create a different schemes. Most commons are 2 of 3 or 3 of 5, where you have a number of share and a subset of those shares would be able to recover the backup. In DuraShare, we use the BIP39 straightforward, and we share each individual word one by one using the same index in the BIP39 from 1 to 2048. We use the Galois field 2053 is the first prime number, bigger than the 2048 that we need, and it creates a human readable share, so you don't have any difficulty understanding and even interpreting what is in there. The key features are one single math that you can do either by software or fully manually. You have no black box, you have no locking, you can run all the process using paper, pen, and a calculator. Again, it's BIP39 native, the full input and output. You can use any wallets available. You don't have to create a different seed. You don't have to transfer funds. All you have today is already ready for backup. It uses Shamir Secret Sharing, for those who are familiar with that, in a K of n. So any fewer than K shares reveal no secret at all. So it's very secure. You have an optional nesting up to 4 layers, meaning you can run a recursive sharing. You can create, let's say, a 2 out of 3 for the first layer, family, professionals, and then the company. And then within the group of family, you can create another setup. Within the professionals, you can create another setup. And with the company, let's say 5 out of 8 with the board members. So you can create a really complex scenario up to 4 layers. So it's a lot. It creates a human readable shares. You can print, you can caveat on the type of printers. The paper here covers. I'm not gonna bother you with all that information. But you create persistent and materials that you can store even for years, right? You can even use metal or other media. We have a built-in error detection that's able to detect honest mistakes or transcription errors up to 3 cells. It even is able to recover one of them, but it's something that we are still working on the implementation side. Another differentiator is a per share audit. You don't have to recover the secret. You don't have to bring all the shares together in order to validate the backup. Okay, you can go in different locations, and we're gonna see how it works. Also, you have a post-recovery checks. We use the BIP39 itself, but we also use ways that you can validate the derivation and even the BIP39 passphrase. So it gives you assurance that you have recovered the original secret. The typical life cycle, we have a different approach here, but the typical life cycle would be you have any wallet, you have your BIP39 seed, 12 to 24 words. You run the ceremony offline, air-gapped in a computer. or other devices, or you can do this manually. It's a little more work, but it's doable. And then you have your shares. In this case, we are representing a 2 of 3. And also a manifest. This manifest is the piece that's going to be that's going to allow us to audit individual shares, and you can even put the information or a hint on the locations and delegate this share to a estate manager or lawyer or someone that will care for the succession plan for this wallet. Okay. Once you have the shares, then you can distribute them. We recommend far different locations, not to create a single point of failure, of course. And again, the share audit ceremony, you just get the manifest and one share, and you can run a validation, make sure that share is exactly as it was from the sharing ceremony without even touching the other shares. They completely untouchable and safe. And then when recovery is necessary, you gather the minimum threshold, in this case 2 shares, and you can opt for a software assisted recovery or a manual fallback. And I'm gonna show you how easy it is to run the math. You get back the BIP39, the same one that you shared in the first place, and you can use any existing wallet to access your funds. Okay, we have a lot of more information here, guys. You can go through that. And one common question that I have when we talk about DuraShare is why not just use MultiSig? MultiSig is awesome for a different use. It's good for signing and expanding rules. It has a silent single point of failure, that is the descriptor. Many people keep the 2 out of 3 in mind and have this feeling that they can lose one of the shares, one of the seeds for the MultiSig, but they can only do that if they have the descriptor, because in order to rebuild the wallet and spend, they need all the public keys. So if you're not aware of this and you're using MultiSig, you are already at risk. So be careful there. Okay. Another informations here explain more how it does the stuff and what it does and how. And a quick comparisons we have here with 2 good approaches for manual sharing. Codex 32, that is becoming BIP93, if I'm not mistaken, and SeedXOR, manual execution, and how DuraShare compares, and also the software assisted is BIP39 and SSKR. Again, nice comparison here. Take a look in the repo. More documents and also implementations. We are going to take a look in the DuraShare HTML. This is the first implementation that we are presenting. A little about the engagement. We have some folks collaborating and engaging, and if you want to know more in depth their contributions, you can find in the Whitepaper acknowledgement. Public record, we have discussed this in the São Paulo BitDevs already. We are eager to discuss and get more feedback. So please, this is the main goal in this presentation, is to ask for feedback. Please engage. And about us, who we are, I am Renato Schiavinato Lopes, the founder and the protocol author. And we have Jeroen van der Graaf, is professor at UFMG here in Brazil. And he's our chief scientist, advisory board, and he's writing a formal paper for the academic side. We want to present this as an academic paper too. So enough of that, let's jump in and get to know the application, the implementation, I mean. In the HTML repo here, you can just download the DuraShare. We are not ready for production yet, so don't use this with real funds. But if you wanted to get the full experience, you can go into the release and run all the validations and stuff that you are probably familiar with, but just run this DuraShare in your local file. For full implementation, we recommend using Tails OS or another amnesic implementation. Okay, so this is the initial look. Let me enlarge that a little bit. It's gonna tell you most of what I just said, and then you start here. Let's start with the natural flow. Create a share. You can put a wallet identifier here. You have the date of creation. If you run multiple sessions, probably this is going to be helpful to keep the shares apart. You can select the three initial here. Again, we have that nested option, so we're figuring out how to create the best usability for this process, but I'm going to stick with 2 of 3 for now. This manual authenticator, we are calling this manual authentication tag, the MAT, is what is gonna enable us to run the manual per share audit. Okay, I'm gonna keep this dual option. With this dual, I'm gonna show you this 2-column validation. It gives us a attacker the probability to fake a share that's gonna pass the test lower than 1 in 4 million chances, and they cannot run brute force because you don't have what to compare to, so it's gonna be just guessing something in that space, so it's pretty secure. I have already some words here, so we don't have to wait. And once I hit the share, generate share, we have then the shares here. So we have the 3 first columns are the words themselves. Again, we are sharing each individual word, and we have this format that we show already, the BIP39 ID and the mnemonic itself. We have a row checksum and a column checksum down here that's gonna enable that up to 3 cells protection. We have the GIC, the global integrity check, that will enable the full comparison plus the share ID. We also have a way to verify that, and we have the 2 layers of the manual authentication tags. Okay, so this is how a share looks like. We have the share number 2, share number 3, and then we have the share manifest. So you can put the location or custodian hint here, and those keys we have here are the keys that will enable us to run a math. So in every line I can use those keys, run a simple multiplication, and then we can validate against the tags. So the manifest will have those 3 shares. Okay, once I hit once I distribute the shares, then comes the opportunity to recover them. So let's start again. Okay, and then I'm gonna recover a wallet. Again, we have this configuration, and I have already one filled here. So share number 1 I'm using, and share number 2. We can input the mnemonic, the words themselves, or the IDs. Okay, it works either way. And even if I'm missing, in this case I'm missing the validation layer or checksums, I can still move on. And I can show here, instead of 162.126, it's gonna present an error in 1 column and 1 line and in the global, so it pretty much defines where the mistake is, and I can correct that. Okay, so recover by hand. Let me get back here and let me present this information here. So to recover from Shamir, probably those who are familiar already know the Lagrange coefficients. Good thing about them, it's public information. It carries no secret at all. So we can pre-compute and even print them and attach one of those with each individual share. And all we need to know is the share number. So for 2 of 3, the scheme that we are using, we are going to recover for share number 1 and number 2. So I just have to use those 2 coefficients there. So let me organize this. So I'm going to recover from share number 1 and from share number 2. And share number 1, my coefficient is 2. And share number 2, my coefficient is 2052. So I don't need the Lagrange coefficients anymore. Let's grab here the value that we're gonna recover. So share number 1, we are gonna use the 1309. So the number here is 1309. It's the first word, right? And for share number 2, we are gonna use 938. So this is gonna be 938. The math we are gonna do is very simple. Just have to multiply the 1309 by 2, the coefficient, and then I have this 2618. And I multiply the 938 times 2052. It's gonna give 1924776. Now I just have to sum those 2 numbers, 2618, and get modulus 2053. It's just divide by 2053 and get the remainder. So I'm gonna divide by 2053. I'm gonna remove, subtract actually the 938 here. That is the integer part, whatever comes before the dot, the 938, and multiply back by 2053. 1679999. I'm just gonna round that. 1680. And if we go back to the BIP39 list and we find 1680, we get the word spin, which is the word we start with. So this is DuraShare. Please engage. The whole purpose of this video is to gather feedback. So you can find more in the GitHub repo or in the GRIFORTIS webpage. Thank you for your time. See you next time.